All right, so today's goal is starting from this one. Well, let me just quickly prove this first, okay? What does this left side mean? This means 1 plus 2 plus 3, because k starts from 1 and gradually increases up till n, right? So it's 1 plus 2 plus 3, da da da, you get until n, right? Now, let's call this s, okay? And what we're going to do is we're going to write s again, but we're going to write backwards. 1 plus 2 plus 3, da da da, n. Okay? And then if we add both sides, we're going to get 2s. And then you get n plus 1. The one before n will be n minus 1, right? So n minus 1 plus 2 will again be n plus 1. So you have n plus 1, another n plus 1, and even here you get n plus 1. So everything that you have, if you add them, sorry, this is a bit confusing. Let me just write like this. Yeah. If you add them, you always get n plus 1. How many n plus 1s do we have? Each one of them gives you n plus 1. How many n plus 1s do we have?
Half of n.
No, we're just simply adding. So there is no half. We're not pairing from the same thing. We're just writing s twice and then adding. Yeah? What did you say?
I said n, half of n.
Yeah, but that will be like how I explained last time. If you have 1 plus n, if you do it inside, that will be half of n, but we're just adding straight down. Since I start from 1 and I go up to n, there will be n of these. Okay? So you have n times n plus 1 equals to twice of s, and now you divide it by 2, and you get the same result. Okay, so this is slightly better than my previous explanation, because my previous explanation of half of n would really work only when you have an even number of terms, right? But this one, it doesn't, you don't need to know if you have even number of terms or odd number of terms, so it's fine. Okay? All right. So that part is quite easy, it's straightforward. But now what about summation of k equals to 1 through n of k squared? What would that be? What about k cubed? K to the fourth, right? So that's going to be the theme of today. But I want to start at a completely different place, okay? So I'm going to abandon this for now, and I want you to think about the following sequence. 1, 4, 9, 16. You know, when you take IQ tests, there's sometimes these type of questions where you have sequences and then you're being asked the next one. Yeah, what comes after this? Should be 25. Yeah, why?
It's going up by 2s every time.
Huh?
It starts off at 3, but it goes up by 2s. Like it starts off going off by 3s, then you have.
Oh, right. Okay, so what Jimmy is saying is that there's a difference between these two as 3 and this is 5 is 7, right?
Yeah.
So now what do you do?
39.
9, which is 25. So that's one way to do it, right? Another way to do this is to say 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. These are all square numbers, right? Yeah. Okay. Did you notice that? Yeah. So the next square number is 6 squared, which is 36. But if you look at the difference between the next one and the before, you see that the differences are increasing, yeah? And it's all odd, right? So in general, here's what's happening. If you have n squared, that's where it ends, and the one before it will be what squared? What goes here? One before. What's one before n?
N minus 1.
N minus 1. So you have n minus 1 squared, right? And the difference between these two, well, let's see. N squared minus n minus 1 squared. If you take the difference, that's n squared minus, well, if you FOIL this out, it's going to give you n squared minus 2n plus 1. This is some algebra. You should take some time to verify that this is true. And if you distribute the minus sign, you have n squared minus n squared plus 2n minus 1. So you get 2n minus 1 as the difference between these two numbers. Okay? Now you can repackage the statement that we just found out in the following way. Here's a question. What is 1 plus 3 plus 5 plus 7? Well, what's 1 plus 3?
4.
4 plus 5 is 9, and 9 plus 7 is
16.
16, right? 16, which is 4 squared. Okay. And now let me make it harder. 1 plus 3 plus 5 plus plus 2n minus 1. What is that going to be? All right, so what is n for this guy? If 2n minus 1 is 7, n is?
And that's
4.
4. 4 times 2 minus 1 is 7, right? Yeah. So n is 4, and you get 4 squared. Get it?
Yeah.
So if you have 2n minus 1, this should be?
4 squared.
No, no.
Oh,
No, if n is not 4, but n is n in general, what would this equal to?
N squared.
N squared. If n is just n, it will be n squared, right? Is that okay? All right. Now, what is n for this guy? If 2n minus 1 is 1, n is
1, 2.
1. Okay? So here's my next challenge. Oh, by the way, did you know this? That if you add these odd numbers, you get all these squares? You knew that before?
I think, yeah.
Oh, okay. There's actually a cool geometric reason why. You know, square numbers can be written as blocks, right? So 4, for example, is 2 squares, and you can put 4 dots, and that's 4 of them. And 4 dots like this, so 2 by 2, right? 3 squared is 9 because of this picture. Right? It's 3 by 3. But if you look at this as 1 squared, and this much would be 2 squared, and this is 3 squared, but look at the difference between 2 squared and 3 squared. The difference is this much, right here. So this much here is 3 squared minus 2 squared. Good? Now, do you see that this is an odd number? Because always there should be something here and it matches here. So these together gives you an even number, but you have one extra. It's an odd number, right? So that's why if you start from 4 and add 1, 2, 3, 4, 5, you get 9, right? Now to go to the next square number, what do you have to do? You have to add these numbers, right? With these dots, which is 1, 2, 3, 4, 5, 6, 7. So next, if you add 7, you get to 16. Right? That's why the geometry that we've just observed gives you exactly this sequence. Right? Yeah. Yes?
I have a question. So for the bottom one, how do you get the 2 squared from that?
Which one? This one?
N squared, yeah, my fault.
How do I get n squared?
Yeah.
That's just making it general. So
That's just general what it equals?
no. What I'm trying to say is that
Yeah, I get the 7.
right.
Yeah.
So I guess I went too fast, but here's a way you think. So you have 2 times 1 minus 1, which is 1, okay? 2 times 2 minus 1, which is 3, plus 2 times 3 minus 1, which is 5, plus 2 times 4 minus 1, which is 7, equal to 16, which is 4 squared. Okay? And then now you write the next one, what is 2 times 1 minus 1, plus da, and you end up with 2 times 5 minus 1, you get 5 squared. And now you generalize, well, what happens if 5 is n? Then you just replace this by n. Replace this by n. Now you're done. Right? Okay. And actually, this is the work that I would have asked the next. So now the next question is, how do you write this as a summation using this? So what should I write? Summation. And let's again use k equals to 1 through n. Okay. So what I want you to do is write the left side in this form. So I want you to figure out what goes in here. And of course, the right side is just n squared, so it's n squared. So what should go in here? Right? Then when k is 1, it's going to produce exactly this. When k is 2, it's going to produce this. Right? And all the way up till k goes to n. Now that produces this last one. Okay? So this guy can be now rephrased like that. Okay. But then, if you recall what we did last time, I showed you how to break up these summations into 2 parts and do stuff like that, right? So now comes something interesting. We already know this, so we could have computed the left side using this, okay? So what's going to happen is that since this is already proved, what we can do is we can rewrite this as 2 times summation k equals to 1 through n, k minus summation k equals to 1 through n of 1 equals to n squared, just like that. Yes. You write it like that. And then you put this in here, and 2 and 2 will cancel. What is this guy? What does this evaluate to? That's like adding 1 over and over again, right? How many times?
N.
So you get n, right? If you add 1 n times, you get n. So you can see that if you plug this in here, cancel the 2, you get n squared plus n, but n is canceled so that you do get that. Okay? So one way to see what's going on is that that observation that we made about the sum of the sequence of sequence of square numbers having exactly odd numbers as differences. Okay, that statement can be proved after proving this statement. All right. So I gave you the proof for this, and now using that, we can prove this cool result that if you add odd numbers, you end up with the square numbers. Okay. However, that's not my goal today. See, as I said, I want the summation of k squares, right? And in order to get this result, let's pretend for a while that we didn't know this. Okay? Let's pretend for a while that we had no idea that it was like this, right? And then we somehow stumbled upon this identity. Yeah. Like if you just play with numbers, sometimes it's this kind of result can just appear out of nowhere, and you just notice it, and then you can start asking mathematicians, is this true or something like that? And then let's say you prove this result by some calculation or something. Okay. Then what's going to happen is once you establish this, you can rewrite it in this form and solve this equation for this guy. And you recover this. You can, in other words, I'm saying that you can go backwards. You can establish some identity that seems right, and then you solve that identity for this unknown thing, so that because this is equal to n, you have 2 times summation k equals to 1 through n, equals to this thing minus n is equal to n squared, so you add in both sides. So you get 2 times summation k equals to 1k equals to n squared plus n. And now you divide by 2. So that's your result, which is same as this guy, if you factor by n, right? You can go both ways, right? But it's exactly this idea that I'm going after, okay?
Wait, so those two things are like the same?
I mean, this implies this implies this. Knowing any one of these will imply the other.
Oh, okay.
Okay, that's what I'm trying to say. 1, 8, what's next?
Oh.
27.
And then you do the cube.
The cube numbers, right? Yeah. 64. Right? And the last one should be n cubed. What's one before it?
And cube minus 1.
N minus 1 cubed. That's different, okay? Yeah. N minus 1 cubed. See, n minus 1 cubed and n cubed minus 1, just plug in 3, for example. 3 minus 1 cubed would be 2 to the third, which is 8, whereas 3 cubed is 20. This will be 26 if n is 3, and this will be 8. So they're different, okay? Yeah. Okay. So you have that, and then, of course, you can try finding patterns by taking the difference. You get 7. What is it? This is 19, and then 7, 37? Yeah, I think. Yeah. Do you see a pattern? It's harder to find this time. There is. Okay, so it just happens that if you just do this, you don't find the pattern. But if you go another layer, this is, what is it? 12, and then 37 minus 19 is 18, yeah. So next one is like 24. Then you get 50. What is it? 61. Yeah. No, it's just meant. Yeah, 61. And then you have to add 64 plus 61. The next one is 125, which is indeed 5 cubed. Okay. So there is a pattern that you can find, but that's not my point. We're not going to do this. Sorry. I just want to calculate this. So let's try this. But to calculate that, I first need to know what n minus 1 cubed is. So let's try that. N minus 1 cubed means you have n minus 1 times n minus 1 times n minus 1, which is n times n is n squared, n times negative 1 is minus n plus 1, n minus 1. That's n squared minus 2n plus 1 times n minus 1. I combine the like terms. N squared times n is n cubed. N squared times negative 1 is n squared. And then 2n, negative 2n times n is negative 2n squared. Negative 2 plus 2n. Right, and then this is plus n negative 1. And again, these are like terms, these are like terms. So you have n cubed minus 3n squared minus plus 3n minus 1. Okay? So that's just some straightforward calculation. And what I'm trying to say is that if you have n cubed minus n minus 1 cubed, that's going to be same thing as doing n cubed minus this thing, so it'll be, everything here is minus, so I'll just switch all the signs, so it'll be minus n cubed plus 3n squared minus 3n plus 1. N cubed cancels, and you get 3n squared minus 3n plus 1. All right, did you follow? Is that okay?
Good.
Let me write it again. It's minus 3n plus 1, and then that's going to equal to 3n squared minus 3n plus 1. Okay, is that fine? Okay. Now let's check that this is indeed what's being added. So what does this become when n is 1? If you plug in n equals to 1, what do you get? 1 squared is 1, so you get 3 minus 3 plus 1, what do you get? 1, okay. When n is 2, what do you get? 2 squared is 4, 4 times 3 is 12, minus 6 plus 1, you get?
7.
7, okay. When n is 3, what do we get? 3 squared times 3 is 27, minus 9. And then, huh? What do you get? Huh?
19.
19, yes. Aren't these exactly these numbers?
Yeah.
Right? So you're doing 1 plus 7 gives you 8, 1 plus 7 plus 19 gives you 27, 1 plus 7 plus 19 plus 37 gives you 64. Okay? Now that we're confident about what's happening to that, we can rewrite the summation. We can write this summation in the following way. I can say it's all of these are numbers of this form, and I get 3 times 1 squared minus 3 times 1 plus 1 plus. This is really a complicated way of writing down 1, okay? And then 3 times 2 squared minus 3 times 2 plus 1 is another complicated way of writing down 7. Okay, let's do just one more. 3 times 3 squared minus 3 times 3 plus 1 is a complicated way of writing down what number?
19.
19, right? And then plus da da da. At the end of the day, we are going to have 3n squared minus 3n plus 1, which is this guy right here, 3n squared minus 3n plus 1. But it's like, to get here, what do? You go under the tunnel and then exit out of the subway, right? Yeah, if you add these numbers, you get to the next stop, right? So if you added this much, what's the result?
N cubed.
N cubed. Okay? And just bear with me, we're almost there. We can now figure out what summation of k squared is, because now we can rewrite the left side as a summation. What is it? K equals to 1 through n of what goes inside here? To express the entire left side as this form, what goes in here?
3n squared minus
Not n,
Okay.
3k
3k squared minus 3k
plus 1.
plus 1 equals to n cubed. Right? If you start from 1 and then n, you get everything on the left
So I
side.
have a question.
Yeah.
Wait, so that is for the k squared?
No, I'm trying to get to here.
Okay.
I did all this work because I want to know this.
Oh, okay.
Okay? Yeah.
So it's like working towards it.
Yeah, I'm still working towards it, okay? Because I'll be there. Okay, so how do I get this result? What should I do next? I break this apart, right? So I have 3 times summation of k equals to 1 through n of k squared minus 3 times summation of k equals to 1 through n, plus summation of 1, k equals to 1 through n, equals to n cubed. Okay? What is this same as? What's this value? Huh?
N.
N. Because you're adding 1 over and over again n times, right? What's this same as?
3n. 3n?
No, it's this one. It's summation of 1 plus 2 plus 3
Oh,
until n, right?
Oh, okay.
So that part will be n times n plus 1 over 2. Okay? So what you end up with is you get 3 times summation of k squared, which is the thing that we're interested in. We really want to know this, okay? But if you subtract 3 times n plus 1 over 2 plus n, that is equal to n cubed. Okay? Yeah. Now I don't like fractions, so for the moment, let's multiply everything by 2. So I'm going to multiply every one of these by 2 times 2.
Would you do that just to get rid of the fraction?
Yeah, I don't like fractions, so I just multiply by 2, okay? Because then this is going to go away. And now I have 6 times what I'm trying to figure out, minus 3 times, let's multiply this out. It's n squared plus n, okay? And then plus 2n equals to 2n cubed, right? And just move everything to the other side. And okay. All right, I didn't want to erase this, but I guess I have to. Right. So,
I have a question.
yes.
Why would the 3 be negative?
Because there was a negative here, right?
Oh, okay. So
Yeah, but where did this negative come from? It came from this one, right?
Yeah.
But where did this come from? Well, it came from when we expanded this.
Yeah. Okay.
So when we did this, it turned out that minus n cubed minus 3n squared plus 3n minus 1, so that these canceled, but this one became positive, and the other became like that. So that negative 3 is this negative 3.
Wait, where did you come from?
I just invented it. In an equation, you're free to multiply whatever you want, right? Yeah. So I just wanted to multiply by 2 because that will get rid of the fractions, because I think fractions are annoying. Don't you agree?
Yeah.
Yeah. So I killed the fraction. Now I don't have any fraction anymore. And then let's see. You have, if you solve the equation, you have 6 summation of k squared, k from 1 through n, equal to 2n cubed will be on the right side, but then minus 3n squared will be plus 3n squared. Minus 3n will be plus 3n. And plus 2n will be minus 2n. And therefore, that's going to equal to 2n cubed plus 3n squared plus n. Okay?
I'm confused. So how would, if you distribute the negative 3 there,
Yeah.
how would it not be a negative?
It'll be negative, but there's an equal sign, so I moved it to the other side, so
Okay.
it's positive.
Okay.
Yeah. So I do that, and then let's further simplify this by factoring. So if I factor the n, then you get 2n squared plus 3n plus 1. And this is, you can factor a trinomial that looks like this, right? Yeah. So I'm not going to go through, like, you know how to factor things like this? Usually they do something like X chart, and it's like, you multiply the first 2, and then you write it over here as 2, and you put the middle one here, and then you think about 2 numbers that multiply to the top, and then add to the bottom, and then you use that to split vector by grouping. You remember that from pre-calculus? Yeah. But let's not worry about that, okay? Let's just assume that we know that. And if you did the process, you'll see that this gets factored as n times n plus 1 times 2n plus 1. Yeah, I'm not going to be asking you to factor this during an exam, so don't worry about that. Okay, yeah. So if you factor this, it does become this. Okay, and therefore, if I just want this, what should I do?
By 6.
Divide by 6. Yes. So here's the formula that we just obtained. With that long, arduous process, we found out that you have n plus 1 times 2n plus 1 over 6 as the summation. Okay? Yeah. And once you've done this, you kind of see how you can get the other formulas too, right? If you want the k cubed, what do? You just write down all the k, the fourth powers, right? And then look at their difference, write down some summation formula, you can solve it, and then you get a formula for the next one. And you get the next one, okay? But at some point, you can even take a different strategy. So let me show you a different strategy. Um, see, if I expanded everything here, it would have been 2n cubed plus 3n squared plus n over 6. And if I write them individually, it would be 1/3 n cubed plus 1/2 n squared plus 1/6 n. Okay, so that's another way to write down the same formula, right? And if I wrote this down in expanded form, this would be n squared plus n over 2, which is 1/2 n squared plus 1/2 n. Okay. And there are several patterns that you start seeing just by looking at these two, which is that, oh, if you have k to the first power, then you would get n squared with the leading term 1/2, okay? If you have k squared, then you're going to have n cubed with the leading term 1/3. So can you guess by analogy what this would be? Like what would be the highest order term? N to what power?
4.
4. And what would be the coefficient? Come on, this is the pattern, right? 1/2, 1/3.
1/4.
1/4, right? Yeah. It'd be something else, right? Furthermore, of course, when you plug in 0, this should be giving you 0 because when n is 0, there's nothing being added, right? So there definitely should be some n. There shouldn't be any constant term there, in other words. And then there are some numbers that I have no idea of, okay? So here's another strategy. Let's say I now want to know what summation of k cubed is. Then just say, I know it should be 1/4 n to the 4th. That I'm pretty sure, okay? And what I'm not telling you is that this has something to do with the integration. You all know this, right? The integral of x cubed is 1/4 x to the 4th. If this result agrees with the Riemann sum, which can be expressed using this, for those two to agree, it has to really be like this. So there's some deeper mathematical reason why it should be in this form, which I can't explain because it takes too long, but just trust me, bro. That's how I say it. All right. And then there's some unknown number here. And then there shouldn't be any constant term, right? That's what you have. And now what you say is like, okay, I know that when n is 1, right? When n is 1, that better be 1, right? If n is 1, you're only adding 1 cubed, so it's just 1. So it's 1/4 plus a plus b plus C should be 1, okay? Now, we have 3 unknowns, right? A, B, C. How many equations do we need? If you have 3 unknown things, how many equations do we need?
About 3.
3, right? So we just have one equation by plugging in 1 both sides. Now the next one is n equals to 2, right? What's the value on the left side if I have n equals to 2? N equals to 2 means 1 cubed plus 2 cubed, right? So what's that?
Thank you.
9, right? Right, 1 cubed plus
Oh, 1
2,
plus
2 cubed is 8, 8 plus 1 is 9, right? So you have 9 equals to 2 to the 4th is 16, so 16 divided by 4 is 4, plus 8a plus 4b plus 2c. Okay? Next would be 3. Okay, 3 would introduce another plus 27. 27 plus 9 is 36?
36.
Yeah, 36. Okay, so 36 equal to 81 over 4. Okay. This is not that pretty. 27a plus 9b plus 3c. Okay, and then you can solve this, right? If you solve this, you get some numbers, and that actually, after getting those, you can check that for those numbers, this in general works. This works out. Okay. Um, so I'll skip the details because that's just too annoying. But at the end of the day, what's going to happen is that if you do that, you end up with n squared, n plus 1 squared over 4. Okay? In other words, this is same thing as squaring this one. Okay? It's a coincidence. It's a surprising coincidence. Maybe there's a deeper mathematical reason. I don't know. Maybe there's some geometry behind it. I have no idea. But if you take this thing and you square it, you get this. That's how I remember this. There's no other way I can remember this. So let's say that you got this result by pure guess and check. Like it should be this form, and you found out that the number should be that way, and you simplified it, and that's what you have. Okay. How would you know for sure that this is true? Well, there's a way that you can prove results like this, which is called mathematical induction. That's something that I don't want to go through, although in some finite math classes they go through proof by induction, but I don't think, I have so many other topics to cover, so I don't want to do it, but there's some other way to actually prove that this is true if you think it's true. Okay, there's some formal way to actually prove it. But you know what? This result, we actually got it by honest math, right? That this result is, the way we derived it is an honest math, which is actually a proof. Whereas the way I do it like this is more like guess and check. You guess some pattern, it should be something like that, and then after that you have to, if you got your result by just guess and check, then you have to use proof by induction to do it, okay?